Okay, so yesterday I'll just share my screen. Okay, so yesterday we were discussing about whole basis system and shaft basis system. So now, can anyone tell me what is whole basis system? Whole basis system means किती? Can anyone tell me what is whole basis system? Huh? खबर ना?
सर आणि एकदा एक्सप्लेन करा नाल्लो.
बरं बरं. पळय हांव कितें करता एक्सप्लेन मीन्स आतां तरी पॉसिबल न्हू कित्याक म्हाका कवर करपाक जाय सो येस्टरडे एक्चुली आय हॅव टेकन रिकॉर्डिंग ऑफ दीस लेक्चर ओके सो ते पळय तूं आतां
हा सर.
ओके सो रिकॉर्डिंग तुका जस्ट धाडटा हांव मागीर
ओके सर.
सो जस्ट हांव तुमकां परत रिवायज करता सी अबाउट होल बेजीस सिस्टम एंड शाफ्ट बेजीस सिस्टम okay shaft basis okay shaft is basic in this case basic means kide basic size means kide it is always remain constant okay so if you see the shaft anyway this shaft as well as hole okay so both will have tolerance okay एक upper sorry एक lower limit असतले आणि एक upper limit असतले so within this particular tolerance zone we are manufacturing our different components okay so हे जाले shaftaचे now, if you notice here, hole, okay, so this kind of shaft basis system, when we are using, when, okay, we don't want to machine the surface of shaft, okay, we don't want to remove the material of shaft, okay, that time we have to always use this kind of system, shaft basis system. Machine means suppose हांगा पळयल्या तुम्ही, okay, so tolerance zone, this is the tolerance zone of shaft, constant असो तो tolerance. Okay, so throughout it is constant. So this is tolerance zone of shaft. And if you look at this hole, okay, hole. So first, second, third. Now in this case, my whole diameter is variable. First of all, तुमकां खबर आसा shaft आणि hole. Okay, so buckle आणि pen एक example दिलं तुमकां. So buckle आसा ते कितें? It is always hole. And pen जे barrel जे आसा pen आसा ते. Okay, so that is shaft because every time that shaft is going inside the hole. Okay, if I consider shaft, so this shaft is always going inside the hole. Hole means any kind of hole. Okay, so this particular shaft is going inside hole. Now shaft the shaft diameter is constant but in this case okay shaft basis system shaft diameter is constant and my hole diameter is variable okay so that means I can only machine this outer hub okay so machine means this particular hole we want to produce okay so how we will produce that hole drilling okay drill करतले ओके सो सपोज एक एग्जांपल दिता तुमकां सपोज एक कंपनी आसा ओके that particular company is importing this shaft okay the reason can be anything because this shaft material is very costly आता suppose shaft आसा तो suppose gold material आसा so that time it is very costly but हे जे outer hub आसा okay so that is of aluminum material definitely aluminum is cheaper than gold okay so gold material jenna asa that time we don't want to machine this shaft or perform the turning operation of this shaft okay तुका machining करपाक नाका हो shaft आसा तेजे only तू machining कोणाक करतलो hole आसा तेका okay so again and again you will measure this dimension so that how much this particular hole will adjust with the shaft that we will measure right measure करीत वयतलो so in this case continuously I will remove the material of hole okay so that's why if you see this is first second third fourth fifth हे कळ्ळें तुमकां हो आसा तो कितें एक हे सपोज कन्सिडर केलें दॅट इज होल वन मिनट. Okay, so these are the different hole dimensions. So for each hole means when we are removing the material, definitely तुझ्या tolerance zone anyway असतलोच. Okay, I'm always considering tolerance zones, upper limit and lower limit for each hole. Okay, so this is lower limit, this is upper limit. Okay, so now in this case, if we see this particular lowest diameter, okay, was of the hole, suppose if I consider hole number 1, so lowest diameter of this particular hole, okay, that is your lower limit and this is upper limit, that is always greater than highest diameter of your shaft. This is highest diameter. Okay, so this I can consider lowest diameter. कित्याक ह्या आसा ते upper limit, ह्या आसा ते lower limit, right? So अशी जेन्ना condition असता, that time what type of fit it is? Who can tell me? What type of fit? When lowest diameter of a hole is greater than highest diameter of a shaft. That time, what type of fit they are calling? First of all, what are the different types of fit? कोणाक याद आसा पळय? Yesterday I explained you clearance fit, interference fit, and transition fit. कळटा तुमकां कितें सांगता तें? Since always gap is there between these two assembled parts, okay, so this gap is there, so till where? Till here. Okay, so till here whichever shafts are there, okay, those all shaft has to satisfy with clearance fit. Now if I consider this is the tolerance zone of shaft, now each tolerance zone of hole, if I consider one, this one tolerance zone, okay, this one tolerance zone, tolerance zone, tolerance zone, okay, so up to where it is interfering, up to here, sorry, up to here, so up to here it is transition fit, okay, and next this is the tolerance zone of your shaft, it is constant, but tolerance zone of hole it is variable. Okay, now this particular hole it is actually interfering with the shaft. That means kide my diameter of a hole is, see, if I consider this one, diameter of a hole is always lesser than diameter of a shaft. But this is the diameter of a shaft. That means that it will be very difficult to enter into that. Correct? Nahi? So that kind of a fit is called as interference fit. Okay? पण कळटा तुमकां कितें सांगता तें एक्सप्लेन करता तें कांयच कळना.
Aye, sir.
ओके. Okay, so what we'll do, see, suppose if you understood what we have done yesterday, that time, you should able to solve these problems. Okay, exercise दिता तुमकां, just तुमचो drawing book आसा तो लागीं दवर. Okay, so we will solve this exercise. Begin. Okay, so pen card, तुमचो book आसा तो लागीं दवर, and just write this first question. Okay, so this first question, just write this first question. This is important, huh? This exact question is there in your textbook. Okay, so you have to solve this now. Suppose तुमकां काल आमी कितें केलां तें कळ्ळां, so you should able to solve this. This is type, okay, TYPE, type, TYPE. So determine allowances, tolerances, and type of fit for the following dimensions of mating parts. So tolerance find out कर, allowance means कितें तें सांगतो तुमकां, okay, and type of fit. So based on this allowance, we will decide the type of fit. Okay, so just कितें कर, question बरय, वो number A आसा तो पयलीं बरय. So we have to find tolerance of hole, tolerance of shaft, okay, and allowance. So based on allowance, we will decide द टायप ऑफ फिट. तुमकां एक जस्ट पयलीं एक करून दाखयता. सेकंड यू हॅव टू डू ओके बाय युअर ओन. Now in this case they have not given basic size. हे दिला दा कितें तेणी shaft. If I consider this shaft and pole, who can tell me? कोण सांगपाक शकता? हे जे दिला तेणी हे जे दिला ते कितें? This is what? Who can tell me? Basic size is not given in this case. Okay, won't join. See, those who have joined late, okay, we are solving the exercise based on yesterday's discussion. Okay, so this is the first question. So we are going to solve this now. पण ह्या एग्जामीक लागून शिकनाका. ओके, सो दिस इज व्हेरी इंपॉर्टंट फॉर युअर लायफ टायम. तुम्ही जेन्ना इंडस्ट्रीन जॉइन जाता तेन्ना तुमकां कळटलें एक्चुअल कितें यूज तो. दिस इज व्हेरी इंपॉर्टंट. विदाउट दिस यू आर अ फेल्युअर इन मेकॅनिकल ऑर ऑटोमोबाईल इंजिनियर. ओके, हें सपोज कळना तुमकां तूं ऑटोमोबाईल इंजिनियर जावचोच न्ही. Okay, so without wasting any time, I will solve this first question. Okay, okay. So just पळय हांव कितें करता तो. Okay, so question A. So shaft dimension. First we will solve for shaft. Okay, shaft आसता तेजें कितें दिला तेणी diameter. Okay, so कशें आसा तशें बरयता हांव 27.470 mm. Okay, and diameter 27.445. Okay, mm. So this is one thing. And about hole, see, always shaft is going inside the hole. Okay, so you have to draw the diagram first, otherwise तुमकां understand जावचें ना कितें जाता. Okay, so diagrams are very important. 27.523 523 mm. Okay, now just look here. आता फर्स्ट कितें करता हांव जस्ट एक शाफ्ट काडटा. ओके, शाफ्ट. I will draw shaft first. Okay, I'll draw somewhat bigger. Okay, so this is shaft. Now diameter is given. Okay, so this 27.470 कोण सांगपाक शकता हें कितें एक्चुअली. See, we are removing the material from both sides, right? Suppose हो तुमचो shaft आसा, turning कशें करता तुमी. Okay, so both sides. So we have to actually consider the tolerance on both sides. Okay, but आमी most of the time दाखयना. Okay, so only कितें highlight करता हो जो तुजो tolerance आसा एकूच tolerance highlight करता. So this is the tolerance, correct? So this is the tolerance. So whatever they have given in this case 27.470, that is upper limit. कळटा तुमकां. आनी हें आसा तें कितें लोवर लिमीट. कशें कळ्ळें अप्पर आनी लोवर. Since this value is bigger, see 27.470, but this value is lesser, so always bigger value will be our what upper limit. So 27.470, and this is lower limit. Lower limit कितले आसा 27.445. so this is about shaft. Okay, so similar thing हांगाय बीन आसतलें. so हांगा दाखयना हांव तें कळ्ळें तुमी. Okay, so diameter दिला radius न्ही, so it is diameter. So just ignore this full diameter thing. कळ्ळें तुमकां. Okay, so now next is hole. Okay, so this particular shaft I am always entering inside hole. आता hole कितले दिला It is given as, first it is given as 27.500. So this is what lower limit. Lower limit किती आहे? If you consider this value 27.523, it is bigger. So bigger असतात ते किती आहे तुमचे? It is upper limit. Okay, now I'll just, as per this dimension, okay, just estimate करता, assume करता. आता वो value किती आहे? 27.47. So definitely, okay, ऐका या किती करता आता? This particular value 27.470. Okay, so definitely this particular value 27.500 is greater than 24.470, obviously. Okay, so greater असा तशें हांव ड्रॉ करता. आता greater means कितें? Okay, so just on एक line ड्रॉ करता. So in this case this is whole. Okay, हांव जे ड्रॉ करता that is whole. Okay, and my upper limit कितले आसा? 27.523. So upper limit. Okay, so limits पयलीं ड्रॉ केले हांवें. Now I am drawing that hole. Okay, पळय this, all these are actually cross sections. कळ्ळें न्हू? Exactly at a middle I have taken the cross section. So confused जायनाका. This is what? Tolerance zone. Tolerance zone. Okay, so as per that, just I'll write it here. Okay, so lower जे आसा, this is lower limit and this is upper limit, right? So lower limit कितले आशिल्ले? 27.500. Okay, and upper limit 27.523. Okay, so in similar way I will draw this uh, पळय इमेजिन करपाक शकता तुमी ड्रॉ केला तें. दिस इज एक्चुअली होल. ओके, आय हॅव टेकन क्रॉस सेक्शन. होल मीन्स कितें कळ्ळें तुमकां? सपोज एक बेरिंग घे. बेरिंग इज ऑल्सो अ होल बिकॉज शाफ्ट इज ऑलवेज गोईंग इनसायड दॅट बेरिंग. ओके, सो हो बेरिंग क्रॉस सेक्शन सुद्दां कन्सिडर करपाक शकता तुमी. सो जस्ट जॉइन दीस. कळटा तुमकां? ओके. Okay, so this is the tolerance which I provided on inside diameter of my bearing. Inside diameter of my bearing. Okay, so similar way हांगा सुद्दां तुमचे lower limit same आसतले, upper limit same, but don't waste time. Okay, so directly we will solve. So first thing what they have asked in question, allowances and tolerance. Okay, so first we will find out the tolerance. So what is the formula for tolerance? Okay, so one by one we will see. So answer. So first we will find out the tolerance of hole. Okay, now what is the formula for tolerance? पळय this हे जे आसा ते तुमकां tolerance म्हणून सांगना. So if you do upper limit, so if I consider this as an axis, okay, this particular distance from axis, that is upper limit, and this particular distance, that is lower limit. Okay, so upper limit minus lower limit, if I do, I will get this particular distance. Correct काय ना? हे minus हे suppose केलें आमकां हे distance मेळटलें. So हे distance जे मेळटा, that is our tolerance. Okay, so we'll just पळयात simultaneously you should solve. Okay, so upper limit minus lower limit. Okay, so upper limit of hole, how much it was? 27.523. Okay, minus 27.500. 5233. 523. Okay, correct. So how much? Answer. पळय सॉल्व करून सांग म्हाका. जस्ट बसून राव नाकात. ओके, how much answer you are getting? Askar, Ankit, Piyush, Pranay, how much answer you are getting?
So 0.023.
Correct, exactly 0.023. Okay, so I'll just write it here. 0.023. 2, 3 mm. Okay, so already you have found out tolerance of a hole. Now next thing, tolerance of shaft. Okay, it will be always same, upper limit minus lower limit. Okay, so upper limit minus lower limit. Okay, so तुम्ही सॉल्व कर, अप्पर लिमिट कितले आशिल्ले शाफ्टाचे 27.470 minus 27.445. Okay, so answer should be कितले जाता 0. Sorry, this is not okay. 0.025, correct? Okay, now next thing what they have asked, we have to find the allowance, correct me? Question किती दिलं? Okay, tolerances and allowances. Okay, now what is allowance? पळय हां सगळे झाले तुमचे सॉल्व करून. What is allowance? See, if I consider one shaft, sorry, not the middle, if space is there, if I consider one shaft, okay, okay, so always tolerance will be there for shaft. Okay, upper limit and lower limit. Now again, this is my hole. Uh, okay, so this particular shaft is going inside the hole. Now this is tolerance zone of what? Hole, and this is tolerance zone of shaft. Now what is allowance? Now allowance will be always, okay, always whatever the gap is remaining between your minimum hole and maximum shaft. Okay, so हे जे गॅप उरता तुजे, हे जे गॅप उरता तेका हांव कितें म्हणटा, अलावन्स म्हणटा. ओके, सो अलावन्स फॉर्मुला कितें जातलो कोण सांगता म्हाका? It is the difference between minimum hole and maximum shaft. Okay, so my allowance value will be what? Minimum hole खंयचो जाता? What is the lower limit? Okay, so this is your minimum hole. Okay, so allowance is equal to always lower limit. Allowance means कितें? कितले allow करता. Okay, चड allow केलें जाल्यार कितें जातलें? तुजें लूज जातलें, रायट? शाफ्ट लूज जातलो. Allowance जर सामकें कमी आसा, नेगेटिव्ह सपोज allowance आसा, okay, that time it will be interference speed tight आसतली. Okay, so lower limit minus, oh sorry, lower limit of hole minus upper limit of shaft. Okay, so that will be equal to, in this case, third one, allowance equal to upper lower limit of a hole, how much it was? 27.500. Okay, minus upper limit of a shaft, so 27.470. So based on that, you get an answer of 0.03 mm. Now, based on this allowance, I have to decide कितें type of fit, whether it is clearance fit, transition fit, or interference fit, type of fit. In this case, it is difficult to decide, okay, for transition feet. Okay, now always remember, if this allowance value is positive, okay, so if allowance is positive, that time whatever fit you are getting, that is called as clearance fit. Okay, and if allowance is negative, that time it is interference fit. इंटरफियरन्स फीट. इवन तुमकां डायग्राम आसा तेजे डायरेक्टली ड्रॉ करता तेन्ना कळटा कसले टायप ऑफ फीट ते. ओके, सो इफ यू लुक एट दिस डायग्राम, definitely the highest diameter of your shaft is lower than lowest diameter of your hole. ओके, सो तेका लागून कितें उरतलें हांगा गॅप उरतलें. हेजे गॅप जेन्ना उरता तुजे, दॅट टायम इट इज ऑलवेज वॉट टायप ऑफ फीट? क्लियरन्स फीट. कळटा? हां, ओके. सो झाला सॉल्व करून. ओके, नेक्स्ट प्रॉब्लेम. जस्ट सॉल्व नेक्स्ट प्रॉब्लेम. सो जातकीर सांग म्हाका. कोणाक डावट आसा हांगा? जस्ट प्लीज लेट मी नो. एनीवन? पळय, एनी डावट सपोज सांग कोण कितें सांगता.
No, sir. No doubt.
ओके ओके. अथर्व, प्रणय, एनी डावट?
ना सर.
ओके.
सॉल्व इतलेच करप न्हू.
हय, इतलेंच करप. आतां दिला विचारला कितलें तें टॉलरन्स फायंड कर आनी एलावन्स फायंड कर. सो इतलेंच सॉल्व करप. कळ्ळें तुमकां? सो 2021 आय थिंक दे हॅव आस्क्ड वन क्वेश्चन बेस्ड ऑन दीस अलावन्सीस एंड टायप ऑफ फीड. ओके. Okay, so let's move to next question. Okay, so just try this for your homework solve कर आणि म्हाका सेंड कर. हांव तुमकां सांगता whether it is correct or not. B, question number B. Okay, so just it is for homework. It is similar way. Okay, so just तुम्ही solve करून पळय पयलीं. Now I am solving this question. Okay, a 50 mm diameter shaft rotates in a bush bearing. Okay, the tolerance for both shaft and bearing is 0.05 mm. टॉलरन्स दिला आणि अलाउन्स दिला. अलाउन्स कितलो दिला? 0.10 mm. Now in this case, allowance is positive, negative sign is not there. That means what type of fit it is? कोण सांगता? Okay, we'll see that afterwards. Okay, so find the dimension of shaft. आता exactly opposite होतं. Find the dimension of shaft and the bearing on whole basis system. What is the meaning of this? Whole basis system. कळटा तुमकां? What is whole basis system and shaft basis system? In whole basis system, what is the size of hole? Okay, what is the diameter of hole? कोण सांगतो? And in shaft basis system, what is the diameter of shaft? Okay. See, in whole basis system, तुमकां कितें सांगलें? Whole basis system. Okay, basis means तुमकां basic size याद जावपाक जाय every time. Basic size. Okay, now what is basic size? Okay, whatever the dimensions we are getting after doing design calculation. Okay, so those particular dimensions is called as basic size. Okay, so this thing will be decided by your designer. आता suppose तुझी whole shaft and whole assembly आसा. Okay, shaft assembly and whole assembly. आता directly असे draw करता कळपाक जाय. Okay, So this particular shaft is going inside this hole. Okay, so here definitely tolerance zone astalo. Okay, so tolerance zone आणि here tolerance zone असतो. Okay, now basic size. या तुमकां खबर आसा upper limit, lower limit. Okay, now this is lower limit, upper limit. Now basic size, okay, will be there somewhere in between. Okay, in between or here also it can be there. Okay, but you have to always remember that basic size will be same for both shaft as well as hole. Okay, so this is your hole and this is shaft. Okay, always remember, आता suppose basic size असा, basic size I will just give you 30 mm. Okay, so this upper limit is below this 30 mm. Okay, so in case of shaft it can be around just 29.5. Okay, and in lower limit 29.3 mm. Okay, so in this case we are deciding upper limit and lower limit with respect to basic size. Okay, shaft असं त्याचे दाखवली already. This is lower limit and upper limit. Now in case of hole, again we will decide our lower limit and upper limit with respect to basic size. With respect to basic size. So this can be somewhere in between 30.3 and upper limit 30.5. Okay, so for both hole and sorry, for both shaft and hole, basic size will always remain same. Only आमचे change किती जाता, upper limit definitely should be different, lower limit should be different. Okay, for both, for shaft it is different, for hole it is different. Now what is hole basis system? Now in this case तुमका सांगलेले hole is my basis. आता पळय हेच example consider करता. Okay, same example I will consider shaft. In this case slightly I'll draw bigger size. Okay, so this was the tolerance of shaft. Okay, आता पळय okay, fine. So next hole. Okay, so tolerance of hole. So the other view आणि draw करता. Okay, so हांगा तुमचो असो. Okay, this is other feature. Now this is the hole. Hole. So tolerance zone of hole, shaft, tolerance zone of a shaft. Now what is hole basis system? Basis system. Now तुमका किती सांगलेले? Somewhere in between my basic size will be there. So somewhere in between, it can be anywhere. Okay, so always remember in hole basis system, my hole will be always of basic size. Always of basic size. That means किती? जी तुझी basic size line जी draw करता, that will exactly meet your lower limit of a hole. Suppose if I consider this as 30 mm, consider केले. Okay, now in this case, your lower limit of a hole will be also equal to 30 mm. Okay, now hole basis system. I'm just put it down. Hole basis system. Okay, lower limit of hole will be always equal to what? Basic size. Basic size. Okay, in similar way, suppose if I consider shaft basis system. Shaft basis system. किती जातले? किती जातले? Shaft will be basic size. Okay, shaft size will be always equal to basic size. But in this case, shaft size means किती? Always I will consider upper limit of a shaft. Okay, now in this case, upper limit of a shaft will be always equal to basic size. Okay, upper limit of shaft will always equal to what? Basic size. Oh, anyway, tolerance zone असतो तुझो, but हे जे आसा ते एक्झॅक्टली मीट जातली. इन दिस केस 30 mm. हां, कळ्ळें तुमकां हें डिफरन्स कळ्ळो? शाफ्ट बेसिस एंड होल बेसिस सिस्टम. You have to always consider upper limit of a shaft will be equal to basic size for shaft basis system. आणि होल बेसिस सिस्टम असते का लोअर लिमिट कन्सिडर कर. ओके, लोअर लिमिट मीन्स हे. अशें कित्याक कन्सिडर करप पळय शाफ्ट बेजीस सिस्टम आनी होल बेजीस सिस्टम बेजिकली केन्ना यूज करता म्हणून सांगलें मशिनींग करपाक ओके सो मशिनींग आमी जेन्ना करता ऑलवेज वी हॅव टू कॉन्सिडर अवर मॅक्झिमम लिमीट आतां हो शाफ्ट आसा तुजो ओके शाफ्ट आसा सो शाफ्ट आसा तेजें मटेरियल कसो रिमूव करता तूं from here I am removing layer by layer I am removing right so in that case I have to always consider maximum size of a shaft मिनिमम कन्सिडर केल्यार कितें जातलें तुजें मटेरियल रिमूव करून आनी कमी जातलें सो एक्झॅक्ट तुका दिवपाक लागून आमी मॅक्झिमम कन्सिडर करता नाव इन दीस केस होल in this case whole how I am removing the material layer by layer from here I am removing the material whole मोठो करपाक okay here means कितें हें कितें तुजें lower limit of hole okay so also material remove करता तूं but in this case you are removing material from this side okay downwards for shaft okay so that's why in shaft based system we have to always consider upper limit of a shaft which is equal to basic size. So any doubt in this? Please let me know. Any doubt in this?
No, sir.
Okay.
ना सर.
Okay. So तसं जाल्यार problem ते solve करता. So first कितें दिला ते okay. Now okay whole basic system दिला that means तुमकां कळपाक जाय in this case कोण सांगता म्हाका what is my basic size? Basic size कितली आसतली? पण डायरेक्टली त्या बेजीक सायज इतली आसतली म्हण दिवचें ना ओके सो तुमकां कितें आतां कस्टमर आसा कस्टमर तुका तुमची कंपनी जी आसा ताका सांगतलो म्हाका एक 30 डायमिटर आशिल्लो शाफ्ट जाय ओके सो तो जो शाफ्ट तुजो डायमिटर जी तेणें जी सांगला ओके ती तुजी ऑलवेज बेजीक सायज आसतली कळटा तुमकां आतां हांगा कितें दिला 50 डायमिटर शाफ्ट ओके सो जो कस्टमर आसा तो डायरेक्टली तुका सांगतलो 50 शाफ्ट जाय म्हणून तुका 50 डायमिटर आसलो शाफ्ट जाय सो इन दीस केस माय बेजीक सायज इज 50 जेन्ना तुका टॉलरन्स बीन कांयच दिल्लें आसची ना ओके 30 10 25 right that time it is always basic size okay now with respect to this basic size I have to find out the tolerances or I have to find out dimension of a shaft tolerance I already did that okay now this particular shaft rotates in a bush bearing okay now in this case which is my shaft is already given okay now hole कितें आसतलो what is hole in this case see this particular shaft it is going inside the bush bearing okay so this particular bush bearing is my hole कळटा तुमकां कळटा काय ना every time that shaft is going inside the hole so bush bearing will act as a hole कळ्ळें so next thing the tolerance for both shaft and bearing is 0.05 no problem दोन्ही एका सेम टॉलरन्स दिला ओके आणि अलाउन्स दिला तो 0.1 and that allowance is positive so from this data you should able to draw the diagram okay just try कर ओके सो हांगच्यान इतले सेंटेन्स जस्ट रीड कर हे मागीर पळोवया फायंड द डायमेन्शन शाफ्ट ते मागीर पळोवया सो फ्रॉम हियर टू हियर यू शूड एबल टू ड्रॉ द डायग्राम एंड जस्ट कन्सिडर दीस होल बेजीस सिस्टम नाव दीस होल बेजीस सिस्टम इज गिवन दॅट मिन्स कितें तें कळपाक जाय तुमकां See, I don't know whether I will be able to complete this. Detail सांगपाक टायम जाय नुसतो अदरवायज आनी एक्स्ट्रा घेवचे पडटले फाल्यां बरयला तुमी क्वेश्चन बरयला फर्स्ट ऑफ ऑल okay so I start now so in question just question read कर so already सांगलेलें तुमकां a 50 diameter shaft okay so basic size will be always equal to 50 mm. Okay, so किती किती दिला ते पयलीं पळय. So in this case bush bearing दिला. So in this case bush bearing किती आसतलें तुजें hole आसतलो. Okay, that will act as a hole. The tolerance for both shaft and bearing. So tolerance for shaft and bearing, that is hole बरयता. Bearing will be always equal to hole. Okay, so tolerance for shaft and hole equal to 0.05 mm. Okay, and allowance always equal to what? 0.1 mm. Okay, and one more thing is given, that is hole basis system. Okay, so from this data I will just try to draw the diagram. किती करता हूँ पहले? First of all shaft to draw कर. पळय हो shaft तुमच्या एक्झॅक्ट आसपाक जाय अशें ना. ओके, सो जस्ट ड्रॉ कर. ओके, सो नेक्स्ट तुजो होल आसा, जस्ट ड्रॉ करता हांव होल. ओके, सो okay, so now I will draw tolerance limit. Okay, or tolerance zone. इतले पयली ड्रॉ कर. Okay, so now they already told you that basic size is 50 mm and hole basis system. That means whenever hole basis system is there, that time what I told you, किती सांगलें?
Sir, lower limit.
Correct, exactly correct. So lower limit of a hole, okay, lower limit of hole, that is always equal to basic size. So in this case, okay, ह्याच्या lower limit आसा तुझे ड्रॉ केला, तेजी सायज कितली जाली? So this particular distance
50 mm.
50 mm. खंयच्यान हांगच्यान हांगा 50 mm. पळय कोण जॉइन जालो लेट आतां इतलो? वेदांत एटलीस्ट टायमार तरी जॉइन जावपाक जाय न्ही. तुजो लेक्चर पळय काबार जावपाक वेदांत वे पळय.
सर आत्ता उठला सर, काल लेट.
ओके, एनीवे, सो हांगा जस्ट पळय वेदांत. ओके, सो तुजे 50 mm जालें. नाव नेक्स्ट थिंग दे टोल्ड इज कितें सांगना आनी कितें सांगना, कितें बरयलां? बूट सायज होल. Okay, tolerance of hole and shaft will be always equal to 0.05. Okay, so now this tolerance is given. How much it is? 0.05 mm. Okay, tolerance of hole as well as tolerance of shaft will be always equal. कितले? 0.05 mm. Always equal न्ही. So in this question it is given that both have same tolerances. And now allowance is given as 0.1. What is the definition of allowance, or what is the formula of allowance? कोणाक याद जाता? allowance means कितें? हे जे गॅप जे उरता भितर तेका हांव allowance म्हणटा. कळ्ळें न्ही? ओके, सो इन दिस केस allowance is कितें? lower limit and upper limit of hole, upper limit of shaft and lower limit of hole. Okay, so if I do lower limit of hole minus upper limit of shaft, definitely I will get this distance. Okay, so that particular distance is called as allowance. कळ्ळें? So allowance जो आसा हांगा बरयता हांव, कितलो दिला? 0.1 mm. सो इतलो तुमकां डेटा दिला. So from this data, all this thing, you have to find the dimensions of shaft and hole. Okay, so dimension of shaft and hole. Dimension will definitely, along with upper limit and lower limit, you have to find. Okay, so first thing बरयता. First we will find about hole. Okay, so बरय just upper limit of hole. इक्वल टू कितें जातलें आतां सी this particular okay upper limit हे फायंड कर म्हटलं सो अप्पर लिमिट मीन्स डेफिनेटली कितें ही तुका सायज खबर आसा 50 mm तुका खबर आसा ते 50 mm जे दिला ते कितें तुजें लोवर लिमिट correct so if I add this particular tolerance value in lower limit I will definitely get this upper limit this particular tolerance value if I add into this lower limit definitely I will get upper limit correct kind of okay so in this case I will write it as upper limit of whole okay upper limit of whole equal to lower limit of whole plus tolerance value that is yes tolerance for example okay so lower limit of whole already खबर आसा तुका 50 mm plus tolerance कितना दिला 0.05 okay so if you find that answer will be direct कर okay 50.05 mm correct okay so now let's find lower limit of whole equal to what okay equal to what हांगा ऑलरेडी मेळा तुका आन्सर लोअर लिमिट ऑफ होल आमची आसा जी कितें होल बेजीस सिस्टम आसा सो इन होल बेजीस सिस्टम लोअर लिमिट ऑफ होल विल बी ऑलवेज इक्वल टू बेजीक सायज okay now in this case basic size is 50 so that means कितें lower limit of hole equal to basic size which is equal to 50 mm मेळ्ळें आमकां right so next space मध्ये cover just साइडीन now next thing is about shaft second is about shaft so about shaft okay first we'll find upper limit of shaft पळोवया कितलें जाता upper limit of shaft okay so कितलें जातलें upper limit of shaft कोण सांगता म्हाका कोण सांगता डायरेक्ट पळोवन काडपाक जाय अप्पर लिमीट हें अप्पर लिमीट जें आसा हें अप्पर लिमीट तें आमकां फायंड आउट कर म्हाका हू कॅन टेल मी सांग सांग see upper limit of first shaft will be equal to what will be equal to what huh? will be equal to what upper limit of a shaft okay upper limit हें जें आसा upper limit of a shaft that will be equal to okay ही तुका खंयचें आतां खबर आसा you already know the lower limit of a hole and you know the tolerance value correct you know lower limit of a hole and tolerance value okay so in this case my upper limit of a shaft will be 50 okay lower limit minus 0.1 correct काय ना ओके सो 0.1 आसात कितें हें तुजें कितें तें तुजें एलावन्स कळ्ळें सो 50 upper limit of a shaft will be equal to 50 कितें तुजें it is a lower limit of hole minus allowance okay so lower limit of hole कितलें आसलें 50 minus 0.1 right allowance was 0.1 so 49.9 mm so this is your upper limit of shaft now you have to find the lower limit of a shaft lower limit of shaft कितें जातलें will be equal to what डेफिनेटली हें कळपाक जाय तुमकां पळय अप्पर लिमीट ऑलरेडी मेळ्ळें तुका okay so this is upper limit of first shaft you already got this upper limit okay ते कितें केलां हांवें लोवर लिमीट ऑफ अ होल this limit minus your allowance value that was 0.1. So तशें करून आमकां upper limit मेळटा. Now lower limit of a shaft, how you will find? See, this tolerance value is already given, that is 0.05. Okay, so lower limit will be what? This particular upper limit minus this particular distance. If you do, definitely I will get this distance, that is lower limit. Okay, so upper limit will be equal to, sorry, lower limit will be equal to upper limit of a shaft minus tolerance value. Okay, so are you getting? Okay, so upper limit of shaft minus tolerance value. Now what is, we have already found out the upper limit of a shaft, that is 49.9 minus tolerance value is given as 0.05. So how much it is? Just find out. 49.9 minus 0.05. Okay, so it will be 49.85. कळ्ळें तुमकां? So this kind of problems may come for exam. Okay, so next year. Okay, so I already finished with your this thing, dimensional tolerances. Okay, so next thing is where next we know. Okay, so next thing we will discuss is about surface finishing. Okay, surface roughness, you can say. Okay, yes, तुम्ही just read कर सकते हैं. आता suppose if they are asking in exam, sometimes they will ask, they will tell you to draw the clearance fit. So this everything you have to draw, clearance fit. Okay, shaft you have to show along with that. Okay, shaft tolerance, hole tolerance. Okay, so minimum clearance or minimum allowance, basic size. Okay, so like that, if they ask you about interference feed or transition feed, same thing you have to do. Okay, so ये तुमका PDF form send करता हूँ. So this is interference feed, diagram for interference feed, transition feed, diagram, transition feed. Okay, whole basic system. Yeah, diagram याद दरवाजी गरज नाही. Okay, don't remember this complicated diagram. Only you have to remember this thing. Okay, only you have to remember this thing. Okay, transition feed. Okay, so from A to where? So that tolerance grade from A to H. So next transition system suppose असा J to P. Suppose interference system असा R to ZC. Okay, so that thing you have to remember. Okay, so this is about surface roughnesses. Okay, now in this case, okay, every time either you can do a drilling operation, okay, drilling operation, boring operation, milling operation. Okay, so first of all, in manufacturing processes, I already told you, after drilling operation we are doing what? Boring operation. Okay, why boring operation? Why we are performing that? In order to make the hole smoother. Okay, smoother म्हटलं, smoother means कितें? तुझी surface roughness असना अशी ना. Definitely surface roughness will be definitely there. Okay, but it will be lesser as compared to your whatever hole you got by drilling operation. Okay, just remember that. So for every, okay, if you consider mirror surface also, glass surface also, okay, it is shiny. Okay, तो कितें म्हणटा ताका roughness ना, but in that case roughness will be always there, even if it's shiny. Even if you consider mirror surface, that particular surface will also have what surface roughness is. Okay, now surface roughness can be useful, or sometimes it can be unnecessary also. Now in which case it is useful, I'll just give you an example of a brake, okay, or clutch pad or a brake pad. Suppose if I keep that brake pad very smooth, okay, surface roughness is not there. Suppose if I keep that brake pad very smooth, and you just try to stop your car by pressing that brake, what will happen? What will happen?
स्लिप जाता सर.
Sleeves up there, definitely. So in this case, we want our roughness. Roughness jai patta. Okay, so in this case, roughness is required. Now, if I consider another example, if I consider guide way, okay, so guide way असा तेका surface suppose rough दिला, किती जातले तुझे? किती जातले? Definitely, more friction will happen. Okay, more friction, because of friction, the temperature will increase. Correct? So in that case, our surface roughness will be useless. Okay, it is unnecessary. We don't want roughness in that case. Okay, so that's why guideway surface has to be smooth. Hmm? So that is the importance of this particular subtopic. Terminology, sorry, these are different terminologies. Okay, so surface roughness. And तुमका याद दरपाक गरज ना. Okay, ideal surface roughness, waviness. Now I can say that what is, okay, so हांगानी time waste करपाक नाका. What I'll do, I'll just explain you this thing first. Okay, now what is lay? Okay, I'll start as waviness means roughness. Roughness means you already know. Suppose if surface is roughness, okay, surface is rougher. Okay, so this is called as roughness. Now what is waviness? You should know the difference between roughness and waviness. Suppose if that surface is not uniform, it is rough as well as it is not uniform. Okay, so this particular pattern we can say it is waviness. Waviness, correct? Waviness. Okay, so these features are roughness. You can say roughness. This is called as waviness. Waviness. Okay, roughness and waviness. Okay, so yeah, that is basic. So next thing I will explain you about lay. Okay, so now what is lay? It is the direction of a tool marks or a scratches or grains of a surface which are represented on a drawing with surface finish symbol. That means I'll directly explain with these examples or a table also. Okay, I'll just zoom it. Now you have already performed facing operation on a shaft. Facing operation केला न्ही तुम्ही. Okay, so what you are doing actually, हांगा तुझे कितें आसा, tool आसा. Okay, cutting tool. So this cutting tool, this shaft is always rotating on lathe, right? So this cutting tool simultaneously along with it is rotating, you are trying to bring it at the center, or from center you are moving at the periphery or circumference. Okay, so what type of pattern you will observe in this case? Suppose तुम्ही पहिले pattern कसो आसतलो, like this. Just तुमका circle दिसतले. Correct काय ना? Circle दिसतले. Okay, so these particular circles or pattern we can call as lay. 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 L-A-Y. Okay, याका आमी lay म्हणतात. This is for your facing operation. Now if you consider turning operation, not turning operation. Okay, turning operation. This is shaft. Okay, so you will visible some lines. Okay, some lines will be visible on this workpiece. Notice केला तुम्ही असे lines दिसतात तुमका. Okay, so in this case we are considering it as surface roughness. Okay, surface roughness. So these particular lines or these particular lines we are calling as surface roughness. So for different operation different types of lathe will be always there. Okay, so starting from first. Now this is symbol for lay. Okay, now lay parallel to the line representing surface to watch the symbol shown. Okay, now if suppose we are performing your facing operation for a rectangular workpiece. Okay, so that time tool we will move from this side. Also move karta. So lays will be of similar pattern. Definitely it will be of similar pattern. Okay, so these are tool marks or lay. Okay, so parallel shaping. Next, lay perpendicular to the line. Okay, line representing surface to which symbol is observed. हांगा पळय तुझे जे surface आसा तेका parallel आसा. Okay, but in this case, this is my surface, right? It is perpendicular. These lay are perpendicular. For example, grinding. So you just have to remember these symbols. It can come for exam. It can come. Okay. Now next, perpendicular lay झाली तुझी. Okay, parallel lay, perpendicular lay, angular lay. So in angular lay will be like this. Okay. कसे करता तुम्ही? First, suppose if I performing grinding operation. Okay, so first you will move your tool like this. Okay, then after that you will move it like this crossways. Okay, so finally this kind of a pattern will be observed on workpiece. Huh? So this thing I already told you. Circular lay, about circular lay, example facing operation on a lathe. Okay, so this is circular lay. Multi-directional lay. So multi-directional means it can be anything. Okay, कशाही आसपास शकता तुम्ही. Multi-directional like this. When can we get multi-directional lay? In lapping or honing, whenever we are producing very smooth surface, if you see those slip gauges, okay, slip gauges will have mirror surface, it is very smooth. So again and again we have to perform the operation, okay, either lapping operation or honing operation. Okay, so that time your surface lay will be of different directions like this. Okay, now next is this one, radial lay. Okay, radial lay. Again, radial lay will be like this. Okay, so for example, turntable. Okay, so table is turning and you are performing that operation. Okay, so just तुम्ही किती करा याचे symbol आसा ते याद दवर. For parallel lay, perpendicular lay. Okay, so this is angular lay, circular lay, multi-directional lay, and radial lay. Okay, so next thing, now this is important. Okay, every time, most of the time they are asking you to draw this symbol. So how you will represent this particular roughness? पळय तुमकां एक फर्स्टच हांवें कितें दाखयल्लें, डायग्राम एक दाखयल्लो तुमकां. In that, okay, if you see this diagram, okay, spindle diagram. Okay, so along with all the tolerances, I will also mention these things. Okay, so this is called as surface roughness. Okay, now in this case, surface roughness I kept as 12.5. Okay, on this particular surface roughness is 12.5 micrometer. Why? Because on this particular surface, nothing is coming, bearing is not there. Okay, so smooth, it's a smooth surface. Okay, but if I consider this particular surface, so in this, on this particular surface, okay, so I am mounting the bearing. So in order to mount the bearing, definitely my surface must be smoother. Okay, so in this case it is 0.4. Again if you see, okay, next thing 0.4. So हांगाय बीन तुझ्या bearing येता, correct? So bearing surface हांगा touch जाता, so 0.4. Okay, so as per our application we have to keep that surface roughness. Suppose आमकां purposely आमी rough दवरता, okay, 50 microns we can keep. Okay, suppose smooth जाय, so as smooth as possible, 0.2, 0.4. Okay, so next just we will see the symbol of surface roughness. ओके, सो दिस इज द सिम्बॉल ऑफ सरफेस रफनेस. किती असतं तुमचे? जस्ट लाईक दिस लाईन असं. ओके, सो जस्ट ट्रायंगल और एंगुलर picture असा. Okay, now this E, okay, this everything you should know. Okay, E असा, D असा. What is the meaning of this E, D, A, B, C, F? Okay, actually here some value will come. So what value we have to put? Now A, so A will decide. So let's start from, yes, let's start from A. Now this A will decide the roughness grade symbol. Okay, surface roughness value. ओके, हांवें दाखयलें पळय तुमकां 12.5 आशिल्लें थंय 0.4 आशिल्लें, रायट. सो दॅट पर्टिक्युलर वॅल्यू वी हॅव टू मेन्शन हियर. ओके, सो ऑन दीस पर्टिक्युलर पोजिशन सपोज सरफेस रफनेस वॉज 0.4. ओके, सो इंस्टेड ऑफ A I will put 0.4. ओके, नाव दीस मशिनींग अलावन्स कोणाक याद जाता? इन मॅन्युफॅक्चरींग प्रोसेसीस वी हॅव ऑलरेडी स्टडीड अबाउट मशिनींग अलावन्स. Okay, so that particular machining allowance we will put here. Either it can be 3.5 micrometer or mm, whatever. Okay, mm it is. So this is micrometer, so this is in mm. Now next is this D. Okay, so direction of lay, that particular symbol you have to put. Suppose lay is parallel lay, okay, or circular lay. Suppose if you are performing facing operation on a shaft, that time that particular symbol you have to mention here. Okay, circular lay, parallel lay, or perpendicular lay. So all these symbols you have to mention at this position. Okay, so next, production method, okay, treatment or coating. Okay, that you have to put here. B. आता production method means कितें? Milling, okay, drilling. Okay, now coating or treatment, chrome plating been आयकलां, nickel plating. Okay, so suppose तुमकां different production method जाय. Okay, so that you have to mention here, and coating you have to mention it below this line. Nickel plating, okay, chrome plating. Okay, this F, just forget about this. Okay, other roughness value I will tell it afterwards. Okay, now next is sampling length. Sampling length means कितें? How actually, suppose if I consider roughness, okay, how actually we are measuring this roughness? Roughness means कितें? The distance from this particular peak to the root. So this particular distance is called as roughness. हांगा 0.4 बरयलां. So this particular distance is 0.4 micrometer. Okay, so what is sampling length? Whichever length we are considering to measure the surface roughness. We are obviously we have different instrument for that. Okay, dial gauge suppose use करता तूं. So that time this particular dial gauge probe असा तो हांगा आसा तुजो. So from here you are moving it here. Okay, so this particular length is called as sampling length. So that particular sampling length you have to put at this position 2 mm. Boy, have you understood this thing? Okay, this diagram you have to remember. Definitely it will come for exam. So this particular diagram, E means कितें तें बरोवपाक जाय, A means कितें, B means कितें, C. Only just remember that B, that is your production method, either milling, that will always come above this line. Okay, and your coating or treatment, that will come below this line. C असा पळय. Sorry. Yes, it should come below this line. Okay, हांगा तुजी सॅम्पलिंग लेंथ येतली, सायडीन तूं हें बरय, कोटिंग ट्रीटमेंट बरय. Not below this line, sorry. Below this line, not this line. Mistake केली. Okay, below this line. Above this line कितें येतलें? Production method, either milling, drilling, and below this line तुमचें coating येतलें. Okay. So any doubt in this? Please let me know. Now we will further categorize that particular symbol into different features. Now, Okay, so either I will mention it that surface roughness just like this. Okay, I'm not putting that above bar. अशें suppose आसा तुमचे that time त्याचो meaning कितें? Surface may be produced by any method. No, so no particular method if we are using that time we don't have to put that bar. Okay, तुमकां जाय ती method use कर. Suppose तुमकां particular specify करपाक जाय, milling use करपाक जाय. Okay, so that time you have to put that bar. Okay, so in this case whenever we are putting that bar no, on that particular surface we have to remove material. So material, if material removal is required, always we have to put that bar is added. Okay, now instead of that bar we can also put this circle. Okay, between these two angles we can put this circle means kideं? Removal of material is prohibited. Okay, we don't have to remove material. So that time we have to add circle. हांगा मटेरियल रिमूव करपाक जाय जाल्यार जस्ट एड कर आनी कांय मेन्शन करपाक नाका तुका. ओके, मटेरियल रिमूव करपाक जाय काय ना, that time you just have to draw it like this. Okay, so your simple surface roughness symbol along with bar along with circle. Okay, so these symbols you have to remember. Now how you have to draw those symbols? Okay, कशें ड्रॉ करपाक जाय? Dimension I'm talking about. See, this particular line you are drawing, right? So angle must be 60 degree and 60 degree. Okay, 60 degree. And that particular height if you consider h, okay, this particular height if you consider h, your this height of a line will be always equal to 3h. Okay, so this is how you should draw. कितें म्हटलां हांवें? सपोज हे जर हायट तुजी 1 mm कन्सिडर केला, सो ही जी हायट ही जी लेंथ आसा ती 3 mm आसतली, इंटू 3 करप. ओके, नाव नेक्स्ट. ओके, दिस इज जस्ट एग्जाम्पल. आतां पळय हांगा कितें मेन्शन करप म्हणल्यार सरफेस रफनेस वॅल्यू. ओके, सो बार एड केला मिन्स कितें? We have to remove the material removal is required. Okay, and here above we are mentioning the production method. Okay, or any material removal method, or either you can mention coating method. Okay, so chrome plated, chromium plated, and this is operation milling operation. Yes, okay, above you can mention. Okay, now what we will do, see, one more thing is remaining, so this is very important. What is that? Dhanaraj. See, one more thing, this is very important. Okay, every semester paper they will ask you this. Okay, so just they will give you this one. For N1 which type of symbol you will use? Okay, for N7 which type of surface roughness symbol you will use? Okay, so in this case these are roughness grade number. Okay, हें तुमकां खबर आसपाक जाय. हेका कितें N1 N2 N3 जे आसा, that is roughness grade number, and corresponding roughness value. For N1 roughness value will be 0.025 micrometer. Okay, and corresponding symbol. Okay, so 4 triangles. Okay, 4 triangles means कितें? Your surface roughness is very smooth. Okay, so as we move downwards, surface roughness will keep on increasing. For N12 it is 50 micrometer. Okay, so how we will represent that? Only with a single triangle. So this thing you have to remember. हो जो टेबल आसा तो सगळो तुमकां बाय हार्ट आसपाक जाय. तुमचे जे रफनेस वॅल्यू आसा, symbol आसा, and everything, roughness grade number. Okay, so you have to by heart this table, full table. Definitely they will ask you. Okay, okay, so this thing is not required. So आता किती करूया आमी? We'll just one minute. Time कितलो उरलो? 10:49. Okay, so I started at 9:30. 10. Okay, so some time is remaining till that time. कळ्ळें तुमकां कोणाक डावट आसा जाल्यार जस्ट विचार इफ यू हॅव एनी डावट इन दीस जस्ट आस्क मी ओके 1 मिनिट आं तुमकां क्वेश्चन पेपर सॉल्व करपाक जाय ओके वॉट टायप ऑफ क्वेश्चन दे मे आस्क जस्ट 1 मिनिट प्लीज डोंट लीव क्लास ओके I want to open that PDF. Okay. Machine drawing question paper. Okay. So okay, now I'll share the screen. So now we'll just see what type of question they are asking on this unit. Okay. So starting from our latest question paper, that is 2021, January 2021. Now if you see this first question, okay, first question suppose पहिला तुम्ही directly first question जो आसा तो तुजे ह्या युनिटाचेर डिपेंड आसा. Show how the पळय दिसता तुमकां everyone can you see this just reply दी म्हाका okay
Yes, sir.
okay so just read this first question. Show how the roughness is indicated on a component for the following situations. Okay, so roughness to be obtained without removal of a material. So खंयचे सिम्बॉल सांगलेले याद जाता without removal. Okay, so if we don't want to remove the material, what type of symbol? In this case, okay, so if we don't want to remove the material, so this is the symbol. Okay, this is the symbol you should draw. Okay, along with that full thing. Okay, so circle added, so this thing also you should write circle added. Okay, so now this is the symbol if we don't want to remove the material. Okay, so next surface to be coated. So in this case this symbol coated means तुमचे chrome plating असपाक शकता, right? So nickel plating असपाक शकता. खंयचे सिम्बॉल सांग okay, surface to be coated. Okay, so this symbol you can draw. Okay, just draw this. Along with that you हे mention कर नाका. Okay, so whether it is chromium plated, हांगा एक line आसली हां, here it is, that line is not visible, so either it is chromium plated, so you can just write coated here. Okay, so indicating surface roughness is required. हांगा दिला पळय, just एक example दिला, so you just have to draw this chromium plating. Okay, so in engineering drawing you have already studied, if we want to uh, produce a coating on a particular surface of any surface, you have to always indicate it with the help of this kind of line. Okay, अशें line draw करता आनी तेजेर मागीर symbol घालता. Okay, so this is how you should represent. Okay, now you can draw this particular symbol, okay, for coating. Next, surface to be given a machining allowance. Okay, so machining allowance खंय दिताले आमी तुमकां सांगलेले हो जो आसा तो बाय हार्ट आसपाक जाय. Okay, this particular diagram machining allowance, so here we are providing that machining allowance, right? So you can just draw this symbol either you can indicate this symbol, either you can indicate this bar or not, it doesn't matter. Okay, so what is most important? Machining allowance. Okay, always we are mentioning it here 3.5, any value you can mention 3.5. Okay, here it is 3.5 and these values are in mm. Okay, हांगा तुझ्या micrometer, right? And sampling length will be also in mm. Sampling length, that will be always also in mm. Okay, so next, now, okay, so सांगलें तुमकां, this thing I already told you, but every time they are asking this. Okay, indicate the roughness grade symbols for the following grade numbers: N12, okay, N7, N2. So what are the different symbols which you are using to indicate such kind of a roughness grade? Okay, so just play. Now for N12, N12, okay, so corresponding symbol, if you see, this is the symbol. आणि खंयचो विचारलो N2, okay, for N2 this is the symbol. You just have to draw those triangles. Okay, असे triangles draw करपाचे 1 2 3 4. Okay, so like this you have to draw. Single triangles are single, only single. N7, okay, you have to represent like this. कळटलें तुमकां? Simple आसा, but only thing is you have to remember this table. Okay, so next, okay, N7, N2. Now next question, interpret the meaning of geometrical tolerance shows in figure A. Okay, so we have already studied geometrical tolerances, so based on that, what kind of question can be asked? Which figure they were told? Figure A. Now this is figure A. So do you remember this? So we have to explain the meaning of this symbol. Okay, meaning of this symbol. So which symbol is this? कोणाक येता सर? And which symbol is this? So you just have to write the interpretation. Okay, so symbol A, suppose if I consider this is 1, 2. Okay, so for 1, this particular symbol is run out. Okay, run out. याद आसा run out. So what is run out? याद आसा तुमकां? कशें बरयता तें? And these are datums. Datums. With respect to this datum, we have to check this surface. Okay, so how I will write this? म्हाका खबर ना whether तुम्ही ते read केलं काय ना. So I already told you actually. You have to remember this. I already told you to read all this. Okay, total runout, runout. So when runout is there, so how I'm interpretation, how I'm interpreting the symbol? If I consider this symbol, it is similar, right? Right? So runout symbol, and this is tolerance value, and this is datum A and B. Okay, so whenever we are interpreting that, how we will interpret? So we can write like this: the runout, okay, runout must not exceed the value 0.3. Okay, measured at any point on a surface. Okay, measured at any point normal to the surface. Okay, normal to the surface without axial movement. आम्ही किती करता, जो dial gauge जो आसा न्ही, we are always mounting this dial gauge normal to this surface. Normal means कितें? Perpendicular. So if you consider this axis of a dial gauge and your surface, it must be always 90 degree. Okay, so runout must not exceed 0.3 measured at any point on a surface. Okay, measured at any point normal to the surface. Okay, normal to the surface without axial movement. Axial movement जायना असो कित्याक? So these datums are there. Okay, so this datum, why we are using this datum, these particular surfaces we have fixed. Okay, no axial movement is possible. Okay, so this is how you will write for runout. Now if you consider this second one, okay, there is exactly tapered also. Okay, now in this case runout must not exceed 0.1 measured at any point on this surface, on this inclined surface, okay, without axial movement. Okay, because this datum C is given, so this particular cylinder is fixed. Okay, so in this case you have to read this. Okay, because if such kind of question, definitely they will ask you such kind of question, so you must learn how to interpret the sentence, how to form the sentence based on that. Okay, so if you see here, uh, just I will write down interpretation for this first symbol. Okay, so run out must not exceed 1.5 measured at any point, measured at any point perpendicular or normal to the surface, measured at any point, sorry, at any point normal to the surface without, okay, so without axial movement of a datum A and B. It is like this, you can, without axial movement of datum A and B. Like this you can write A and B. Okay, so next, second one, if you see circularity. Okay, this symbol is for circularity. आता circularity read केला तुम्ही कसं बरोबर okay, so for circularity I will just open that PDF for you. Now this is circularity. So for circularity, how we should interpret sentence. Okay, now if you see here, I want to measure the circularity of this particular cross section of shaft. Okay, circularity and its value. Now how you will write this? The entire periphery of a cylindrical feature, okay, entire periphery of a cylindrical feature, okay, at any cross section, of this cylinder, okay, or at any cross section of this shaft, perpendicular to the axis, perpendicular to the axis, perpendicular to the axis. So ही जी axis असते का cross section is always perpendicular, right? Okay, so must lie, okay, in between the concentric two circles lying at 0.02 mm apart. Okay, or must lie in annual tolerance zone. Okay, in annual tolerance zone, sorry, annular tolerance zone of 0.02 mm apart. Okay, so formed by two concentric circles. आता तुमका सपोज खबर आसा कॉन्सेंट्रिक सर्कल मीन्स कितें तें हें तुमी डायरेक्टली फॉर्म करपाक शकता, रायट? सो सिंपल, इन सिंपल सेंटेंस हाउ यू विल फॉर्मेट इट? नाउ this periphery of a shaft, okay, of a cross section of a shaft taken at any point perpendicular to the axis must lie between two concentric circles, lying at 0.02 mm apart. Okay, like this sentence you can frame. Okay, now in this case how you will frame that? Okay, so this one, the circle is there and 2 is there. So in this case, datum is not required. So in this case, how I will write? Okay, so name is nothing is given. So this feature circularity we have to check. Okay, so the fairy or yes, the fairy of a tapered cylindrical feature अशें बरोवपाक जाता टू सिलिंडर परफेक्ट सिलिंडर ना tapered cylindrical feature, okay, periphery of a tapered cylindrical feature taken at any point or taken at any cross section, taken at any cross section perpendicular to the axis, perpendicular to the axis of component. So periphery of tapered cylindrical feature taken at any cross section perpendicular to the axis of component must lie between two concentric circles lying at sorry lying at 2 mm apart. Okay, so like this sentence you can frame तुमका जाय तसे frame करपा only it should be meaningful. Okay, concentric circle, instead of concentric circle you can write annular circle, it will depend. Okay, so most of the time we will use concentric only. Okay, so this is how you should interpret the symbols, right? So next question, कळटा नहीं है तुमको? Next question. Okay. See, with the neat sketch, illustrate long and short break representation of pipes and shaft. Okay, this question came. Okay, so first sheet asa tejer asa bhai long, okay, and short break representation of pipe and shaft. You should study everything. So next, nothing is there. Okay, so Anika now. So next, now in this case, okay, question came on what is this dimensional tolerances, find the limit dimension for a clearance feed. Okay, so clearance feed is given okay on a whole basis system. Now in this case whole basis system is given, that means my basic size, now here it is directly given the basic size of 50 mm diameter. Okay, so basic size 50 mm will be equal to what? Whole basis system दिला, right? So lower limit of a hole with a minimum clearance of 0.2 mm clearance दिला, right? And tolerance of a hole 0.02 and tolerance of a shaft is 0.5 mm. So आम्ही जे solve केला slightly similarity, only तुमका मातशें twist करून दिला. Just try to solve this, okay? हांवें तुमका solve करून दाखयना, तुम्ही try करात solve करपाचें. Okay, so question number 6, तुमचो तो January 2021 question number 6. Okay, next A. Question number 6A. Just try to solve this. Okay. Now next question came. Draw the sketch to illustrate clearance fit and transition fit. या तुमका directly PDF आन दिला. खंयचे draw करतले? Draw the sketch to illustrate transition fit and clearance fit. So this thing you should draw. Just दाखयता तुमका. Okay, so clearance fit, this diagram you should draw, and next interference, this is transition fit. Okay, so both you have to draw. Next, I think हेजेर एक क्वेश्चन आशिल्लो. Okay. So next question paper. पळया welding जो chapter आसा welding pipe fitting. Just try to solve these questions. Different types of questions they have asked. So तुमकां suppose otherwise this is my last class of drawing, right? So if you have any doubt, please let me know. I will just make one video and send it on group. ओके सो मी क्लासीस सुद्दां अटेंड करपाची गरज ना जस्ट तुमकां टायम मेळटा तेन्ना तो व्हिडिओ पळय ओके सो कितें मातसो सुद्दां कितें डावट आसा तुमकां आय वील मेक वन व्हिडिओ ऑफ दॅट ओके क्लासीस अटेंड करपाची तुमी गरज ना बिकॉज यू हॅव ऑलरेडी फिनिश्ड युअर टर्म रायट सो प्लीज ट्राय टू सॉल्व दीस क्वेश्चन पेपर्स okay so next okay so conventional representation they have asked so single line representation of pipe fitting okay cap cross gate valve this thing symbols you have to study so I provide symbols for the following weld okay weld symbols the plate of 8 mm thickness to be welded now this is the exercise of weld fitting okay weld joint to a 5 mm thickness to be welded on another plate to form T joint okay so yeah just solve करून पळय so in this case, they have given leg dimension, 5 mm leg, convex contour, chipping finish. Okay, chipping finish is on both sides using suitable symbol. Okay, so this they was for 3 marks. Now next, indicate the roughness grade symbols. Okay, again same thing there was for N2, what's the symbol? For N4, what is the symbol? Okay, for N9, what is the symbol? Again that table you have to refer. Okay, so यहाँ नहीं repeat करना. Next, now in this case, next question for it. Draw the symbols for the following characteristics in geometrical tolerance: straightness, position, symmetry. So all those symbols you have to study. Straightness असते symbol कसे सांगणार तुका? Just like this. Okay, position. This is the position symbol. Symmetry. Okay, this is how you should draw the symbol of symmetry. Okay, so each and every symbol you have to study. Now जावचे ना ते. Next. Okay, so conventional representation, freehand sketches of full section, revolved section, pipe layout. Okay, block diagram, pipe layout. Okay, so weld exercise. Now, this kind of question, they may ask you for 6 marks. Okay, so figure 5 shows the orthographic views of a jig plate of a drill jig. Okay, redraw the same and indicate the following in it. At the first point, bottom face of a jig plate to be indicated as a datum A. At suppose just put figure 5 though. Figure 5 bottom plate of a jig plate to be indicated as datum A. Figure 5. Figure 3, figure 4. So, figure 5. Question number 5. Okay, this is figure 5. Figure 5, the bottom face of a jig plate to be indicated as datum A. Ortho show the orthographic views. Okay, now this is the question. Okay, so bottom face, this is jig. Now bottom face has to be indicated by datum A. So datum कसे represent करता तुम्ही? Okay, straight line along with that box and closed triangle. हांगा एक triangle असतो at its foot. Okay, and तेतून आम्ही symbol बरयता. Datum A. Okay, so this was the first question. Right? Now next. Next, top face to be parallel to datum A within the tolerance of 0.2. Why? This one. So they have asked geometrical tolerance. Top face to be parallel, top face to be parallel to datum A within the tolerance of 0.02 mm. Okay, now parallelism. Okay, so above face, top face कशा रिप्रेझेंट करता हूँ okay, now boxes you have to draw 1 2. In this case datum is required. Okay, so what is the symbol for parallelism? Just parallel lines you have to draw in that 0.02. Okay, symbol you have to mention, and here we will mention the datum value. Okay, so this is 0.02 and datum value. Okay, so as to the second one, like this you should keep on solving this. Okay, next then tolerance G6 on a thickness 25. Just tolerance G6 on thickness 25. So the thickness of our value, the tolerance G6. Okay, so this particular value thickness 25. Okay, so how you should write this? You have to draw these diagrams again. Okay, whenever they are asking you such kind of question, full diagram this you have to draw again, and on that diagram you have to show this symbol. Okay, अशें ना की direct symbols दाखयतले. So again you have to draw this diagram. Okay, so 25 here you can write 25 G8. This is how you are writing the tolerance. Okay, so अशें 25 available. Instead of that you should write this G25, sorry 25 G8. That is third one. Next, tolerance H7 on diameter 54 mm. Okay, so diameter G 54 also, this particular diameter. So this is third one. 54. Okay, so how I will write that? 54 H7. This is how you should mention the dimension. Okay, so this 54 is basic size and H7 it is grade. Okay, so this is fourth one. Next, roughness. Okay, 54,000. Roughness of an inner surface of hole 54 mm to be indicated by two triangles. So this is how you should represent the roughness. This is one method. Okay, so two triangles at a diameter 54 mm. So what we'll do? So we'll just check where that 54 mm is. So this is 54 mm diameter, right? So we will never mention that two triangles, okay, two triangles on this particular diameter, okay? So because this diameter or this particular view, this hole is circular or curved, okay? That time we cannot show on this. So instead of that, you have to show like this, okay? Two triangles. This is how you should show the surface roughness. This time, okay, so this was the last question. Okay. So that's a difficult now. It is very easy actually. Right? Now next question. Interpret or Assam. Okay, so either you can answer this or this. Interpret, now in this case you have to write the interpretation. Interpret the meaning of geometrical tolerances for the machine part shown in figure 6 at location 1, 2 and 3. Okay, now we will see next one. Interpretation बरोवपाक जाय 1, 2 and 3. So 1, 2 and 3. So how you will write that interpretation? So 1 means it is datum. Okay, so datum value A is there. Okay, datum, and datum is provided for this particular hole. Okay, so if you look at this component, also then the component असतं. So you have to indicate the particular location. So interpretation बरयता then the particular location तुम्ही mention करपाक जाय. So this is left side and this is right side. Right side. Okay, right? So this particular hole, 1, 2, 3, 4. If I write this particular two hole, it is top. And was also bottom. Okay, so top and bottom. right? So how you will write this first one? First one, datum A. कशें बरयतलें? ओके, सो लायक दीस यू हॅव टू रायट. पळया तुमी थंय सायमल्टेनियसली बरयल्यार बरें, कित्याक हें आनी केन्ना करतले तुमी परत, रायट? सो जस्ट पळय. सो फर्स्ट वन बरयता हांव, इंटरप्रिटेशन. द एक्सीस ऑफ रायट बॉटम होल. ओके, आतां अशें रिप्रेझेंट, आतां खंयचो होल तो कशें सांगताले तुमी, अशें सांगो. ओके, द एक्सीस ऑफ the axis of right bottom hole of a component is indicated by datum axis A. Okay, datum axis A represent केला आमी. Okay, so this particular axis of a right bottom hole of a component is indicated by datum A. So this is datum, right? So next, suppose 2 if I consider, okay, similar manner असतं, the axis of right top hole of a component is indicated by datum B. See this particular hole, second one, okay, this particular hole is indicated by datum B. Okay, so datum axis B अशें बरोबर. So third one खूब कितें कितें आसा, right? So first one, parallelism, okay, and this is concentricity. Okay, concentricity तुझे symbol कितें? This is concentricity. Next, cylindricity, circularity. Okay, so how you will interpret this? Third one, right, left. Third one कशें बरयतलें? So first symbol, A, datum A, and this particular hole. Okay, so hole आसा तेजे parallelism आमी मेजर करपाक जाय, right? So how you will write this? Okay, so this is how पळया कितें बरयता तें. Of this particular hole, so तो hole खंय आसा? left and at top. Okay, so axis, okay, the axis of left top hole of the component, okay, of the component. आता हे कशें बरोवप म्हण सांगलेलें, सर्कुलर सॉरी पॅरलेलिझम मस्ट ऑफ द कंपोनंट lie between must lie between this particular axis. Okay, this particular axis that must lie between two straight line, between two straight perfect lines which are with respect to किती मेजर करता आमी? Datum. Okay, sorry, perfect lines, आणि एक बरोबर perfect lines 0.02 mm apart which are parallel to what? Your datum axis. Datum was A, parallel to this particular axis. Okay, so these particular lines, which imaginary lines, straight lines, are parallel to this particular datum axis, and our profile or our axis is lying between two straight lines at a distance of 0.02 mm. Okay, parallel to 0 which are parallel to datum axis A. कळ्ळें? अशें बरोवप सेंटेंस. आसा काय न्हू? Are you there?
Yes, sir.
Yes, sir.
Okay, so have you understood? So it's already 11:24, right? So I will stop this class. So if you have any doubt, just let me know. I will prepare one video. And today, one extra class is there. Okay, manufacturing process from 4 to 5. So that will be my last class of manufacturing process. Okay. So even I don't know whether I will be there for your next time or not. कळेल तुमका? So please answer well. कळेल तुमका? Please take care, everyone. So last class we will meet. One minute, तुमच्या attendance घेतो.
Thank you, sir.
Yeah, 1 minute attendance घेतो. मागील तुमचं. Okay, so MD practical today is Friday 9:30 to 11:30. So हे सगळे सॉल्व करात. ओके, ईच अँड एवरी क्वेश्चन यू शूड सॉल्व. आता जावचें ना ते, कळ्ळें तुमकां? सो अस्कर एस्टर, 1 minute. अस्कर एस्टर,
Friends.
येस, अथर्व,
Present, sir.
ओके, गैरत, केवल, नेक्स्ट निखिल, पीयूष, प्रणय,
सर
येस,
सर
रजत.
राहुल वाचलं सर मस्त बाहेर गेलो सर सर मस्त हे नेटवर्क येईल सर
ओके ओके,
मस्त बाहेर
अंकित.
गेलो
ओके, अंकित. ओके, रजत.
थँक्यू सर
सोहम, देन सौरभ,
Then, sir.
वेदा,
Then, sir.
नेक्स्ट लास्ट वाकील. ओके, सो कोण करूंक ना ते जस्ट सेंड कर, कोणाचो टर्म वर्क उरलो तो. ओके, नाव यू कॅन लीव द
Sir,
क्लास.
Vedant is also there, sir.
वेदांत घातला मरे तुका, प्रेझेंट आसा वेदांत. ओके, सो
सर प्रेझेंट हा प्रणय
हय, ओके ओके, यू कॅन लीव.
Thank you, sir.
Thank you, sir.
Yes.